Hello, everyone, and welcome to this presentation. My name is Max Körbächer. I'm co-founder of Liquid Reply, and we'll talk today about the state of greenwashing, or how you can build a sustainable and, well, more environmental friendly cluster. I'm also CNCF Tech Environmental Sustainability Co-Chair and CNCF Ambassador. So the challenge which we have today is that data centers around the globe utilize at least 2% of the global energy. And depending on the year, time, and depending on some of the environmental use cases or situations which we are in, these can also mean that we cause up to 2% of the CO2 footprint. And through the upcoming digitalization, the distribution of data, and the growth and the demand of growth of data, we will see that this will grow over the next years, at least 2% more. But there are also very negative estimations, which tells that we go here up to 10 to 12% of global energy consumption for data centers. And therefore, it's very important that we have a look and understanding where we can find all these different carbon emissions and how to reduce them and how to reduce our impact. The transparency here for the power usage is one very crucial, very important key which we are required to have. But besides that, we also have tons of other waste which we see in the information and computer technology area. The key problem is, in the end, that we have a missing link between the data of our power consumption and the data of the caused CO2 footprint. We are living in a dream that we already nowadays can precisely tell how is the energy mix. There's a lot of solutions which tell us this. We also can estimate and calculate most likely for many platforms. But what we can't do is to reflect this in the power contracts and in the costs on the one hand side, but also on the way how we then finally hand over the CO2 impact which we have to our end users. What do I mean with this? Well, if we have in Germany, for example, tons of windmills running in the summer and we have a lot of solar panels, we would wish to move all the compute power during these times and getting kind of payback here for like having a cheaper energy and so on and so forth. Reality is, this link between the power consumption and the given power mix is not yet given, because everything is like going through one big contract. And there's a big problem which we see. However, from an open source and most likely cloud native perspective, we see that we utilize and can and should utilize Kubernetes capabilities as a more unified API across multiple cloud providers to implement a standard way of improving the workload which we deploy towards cloud. But this also can count for your private cloud, for example. So what do we can consider? And no, you do not need to be an environmental sustainable expert here. It's sometimes just enough to think twice about what makes sense to reduce maybe some of your consumptions. So what we can do and what we have to do are two different things. What we can do is to reduce the container image sizes, for example. Pretty easy thing, most of the time very easy to do. We can also schedule containers for a higher density. Who of you out there has a very huge overhead? And with very huge, I mean more than 5%, because everything else is a little bit too much. If you run on a cloud provider, you don't need that much head space. We can scale our containers to 0. Yes, sometimes that feels a little bit difficult. It sometimes feels more like a serverless platform. However, scaling workload to 0 and scaling whole clusters, there's the second part in it, to 0 is a very crucial capability. Because most likely on the weekend no one is working, and most likely in the nighttime also no one is working. And we can do very simple things as exchanging hardware for more newer, modern hardware, which is more performant but also needs less energy. However, this is a very tricky part because it is also good to run old hardware a very long time. You need to roll the dice as what is a better way for you. But what do we have to do? Well, maybe there's a future without containers. Looking at WebAssembly, why do we need containers? Reducing it to maybe 1 2 megabyte in a file size will allow us way faster distribution of applications around the globe. We can store those images without any problem on any kind of node, but we do not need that much space on any of our systems. Startup times are also very fast here. We need to maybe schedule based on carbon data. Finland has a good carbon footprint. Let's move the applications there. Oh, look, Germany finally got the brown coal away. Let's move our data here. And we can scale based on the carbon data. Maybe you want to put your batch into times where you get cheap green energy rather than heavy, expensive, dirty energy. And we can do obviously a lot in the architectural design and in improving especially power management. If you put your server on a private environment into an environmental friendly mode, this doesn't mean that the server shut down. It just means that it restricts, most of the time, it restricts just the amount of how much more energy it can consume on top. So you have less performance in the end. Looking a little bit more deeper into these topics which I have mentioned here. Scale and reduce and right size is one of the key crucial things. It is easy to do, it's fast to do. It often has a very good impact. And overall, it's one of the best way to optimize your systems. So for this, we need to measure, we need to know what is the applications which we have to work on to eliminate waste. And then we need to find a solution for it. And there are tons of nice solutions out there. Auto-scaling groups from cloud provider, okay, it's a good basic start. With Carpenter and KubeGreen, for example, as open source solutions, we can schedule and increase the density of the applications and reduce every other not needed node. With Keda, we can scale through events. And with Kepler and Skefandre, we are able to measure very precisely, actually, where and which of the applications which we're running in the Kubernetes cluster causes the most power consumption and can work here to optimize it. The impact is obviously very heavy and it's very simple to reach. And that's also the power of Kubernetes and why we should run it, because we can use this principle on all cloud providers and especially also on local environments. I bring you here two very nice screenshots from Kepler and Skefandre, which basically show you the power consumption for a certain workload, like an API server or another component within the CI/CD pipeline. And based on this, you can start, improve, you can act. Change hardware or compute architecture is also a very, very great way. It sounds too simple, and it is. You can move on the AWS, for example, to Graviton. And this will cause a drastic cut in the costs in addition. So imagine you run your Kubernetes cluster and you have done all the other stuff, and then you move to Graviton. You will have a very nice impact. We cannot say like, oh, this is like a 50% cut. But realistically, you will see something between 20 to 30% cut of energy consumption, which is needed, or better to say, in the carbon dashboard, which you get provided a couple of months later, that you will save a lot of carbons here also too. And then we need to talk about how we can maybe getting more flexible with our applications. I do not want to name it serverless because I don't think this is the most reliable concept. But scaling applications and functions very fast up and down and reducing the footprint overall, this is something where we can look at. It maybe will not cause in the long run the big reduction of energy, but it will definitely help us to get better if also the whole infrastructure environment can breathe with these changes. Obviously, we need to take a look in the system's architecture. Not every system needs to be real-time. It doesn't need to be huge scaled and 24/7 on. The thing is that in reality, a lot of enterprises running applications that require a constant environment. And this is something which we have to change, and we need to work on it. The impact here can be quite huge, because when you move from a big monolith to a breathing monolith, and a huge microservice environment is nothing else than a monolith, but as long as it can breathe, you can reduce at some point, and this is what we want. Last but not least, but the most heaviest child which we can talk about, is rewrite your software and make it more efficient. Take it as one of the most important things in the software development to write better algorithms, choose the better options when you're writing something, reduce the sizes of the libraries, use something which is lightweight, and so on. But it's a long way. None of us will run out and directly change something out there. So we have to do some little Mythbuster series here, because not everything is always super valuable. The first thing which we need to talk about is time-shifted jobs. It actually, in the real world, has zero benefits for you. And most likely, even the cloud service provider you're running on will not feel any impact on it. Why is that? Well, as I said in the introduction, the energy contract is based and nailed down to a constant stream of a kind of energy mix over a year or whatsoever. It will not give you anything back if you schedule workloads just during the time where you have just pure green energy. You do not get rewarded yet. So this is something which we nowadays don't need to think so much about it. Relocation or following the sun, it is a nice idea, but you really need to do the whole application calculation, especially regards what does it mean if I shift hundreds of gigabytes of terabytes to another location. All of this transaction causes by itself also some energy consumption. So maybe, yes, you in theory on paper will save in the other data center some kilograms of CO2, but maybe shifting around the data back and forth will cause even more CO2 footprint here. And there's also one big myth out there saying optimizing for costs will optimize for CO2. It is not entirely wrong. Yes, it is possible. We see in our daily work that it can reduce the footprint of CO2 if we optimize also for costs, because some of the principles are very close. But if you're talking about writing software new, introducing other architectures, it's maybe not that entirely true. We have seen that, for example, function as a service and Lambda in a large scale costs way more than when you run just a constant monolith. And there's also a recent example where Amazon Prime moves away from Lambdas and run everything in a monolith because it's cheaper. Environmental wise, maybe the Lambdas are better. So, as you saw, you don't need to be an environmental sustainability expert, but you can do a lot if you want to, but do not listen to everything what you hear out there. Speaking of that, we're also here talking about a movement. This is not something which happens from one day to the other, and it means something that you need to live and bring to your environment, to your company, and start at the little simple things and getting better over time. You will not find a solution directly which is 100% suitable at best. You will maybe find something which is giving you a good advantage, and then you can build on it. So join us and help us. From the CNCF Tech Environmental Sustainability, we're looking into how to optimize open source software and how to bring this to everyone out there. And if you can optimize all those big heavy charts, then you will also participate on this and you have some rewards. You can find us on Slack, on the CNCF Slack. We have our own channel. You can find our resources on the CNCF GitHub /tech and sustainability, or just join our mailing list. I know it's a little bit old, but every important communication at least goes through this. And with that, I'm happy to connect with you. Reach out if you have any further question. And if there's nothing else which I can do for you, at least I hope to discuss with you in the future. Thank you.